Okay, here's section 7.7. We're still talking about SOHCAHTOA, sine, cosine, and tangent. And a friendly reminder of what do those ratios actually stand for when you have opposite over adjacent. I'm going to make this bigger, or opposite over hypotenuse, or adjacent over hypotenuse. It's a ratio, so you're comparing how big something is. So if we have a 50-degree angle down here, see if I can get this all on here, a 50-degree angle on here, how big for sine is the opposite side compared to the hypotenuse, because it's opposite over hypotenuse? It is, as you can see, it's not as long, never will be. It's 0.77 or 77 hundredths as big, a little more than almost 8/10 as big as the hypotenuse is. If I change this angle, let me see if it lets you change the angle. So now it's a 41-degree angle. Now it's only about 2/3 as long as the hypotenuse is. So the ratio will change depending on how big the angle is. If I do it this way, the ratio is 0.86. And notice we don't use decimals usually, we use a fraction and put opposite over hypotenuse. But that's what the ratio is showing. Cosine does the same, but now it's comparing the adjacent leg. How big is that compared to the hypotenuse? About 52 hundredths as big, almost half, or actually a little more than half. And the tangent compares the opposite side to the adjacent side. As you can see here, the opposite side is much, much bigger, so you're going to have an improper fraction. But if you have a smaller acute angle, then the tangent side, the opposite, is going to be much smaller than the adjacent side. So those are the ratios that we're working with. And if we work with those ratios, then we can actually find the missing sides of a triangle. Because we might know that this side is 0.66 as big as this side. Well, then if we multiply them out, we can figure out how big that side is. So the first thing you're going to have to do is try to figure out which option am I going to use, sine, cosine, or tangent. You will only use one of those options at a time, one ratio. So first thing you'll do is mark your angle, 30 degrees. You have to find the opposite side, the hypotenuse, and the adjacent side. I would find, if I were you, the hypotenuse first every time. Label the hypotenuse, because you're like, okay, hypotenuse is the long side. It's the side across the 90-degree angles. I know that that's the hypotenuse. Whereas opposite, it's always the side that doesn't touch the angle. So this side is opposite because it's not touching that angle. So I'm going to label that OPP. And then by default, of course, this is adjacent because it's the side next to the angle. So when you see that you have 76 over here on the opposite side, and you are looking for the hypotenuse side, you have opposite and you're looking for the hypotenuse. Nothing matters about the adjacent. What uses opposite and hypotenuse? The sine uses opposite and hypotenuse. So we're going to take the sine. We know the degrees is 30 degrees. And we always make an equation, set it equal to its ratio. Sine of 30 has to be exactly the same as whatever this ratio is. What's the ratio? 76 over x. Okay, unfortunately you can't solve a proportion if the x is in the denominator. You have to multiply it up over into the numerator. So we cross multiply and put the x up here. X times the sine of 30 degrees equals 76. But then we've got to divide to get x by itself. We're doing algebra here. We're just doing some algebra with some bigger, more awkward-looking trig ratios. Divide by sine of 30, divide by sine of 30. Oops, that's not an S. 76 over the sine of, I did it again, sine of 30 degrees. How big is that side? We're going to have to take our calculators. and type in 76 divided by the sine of 30 degrees, parentheses, equals 152. So that side just so happens to be 152. X equals 152. Go back to the beginning of the chapter. I know this seems like a long time ago, and I don't know why they put special right triangles in the same chapter as trig. Well, I do, because they're finding sides of a triangle, but it's so different. We just found how big angle X is if this is a special right triangle. Would have been way faster to use x squared of 3, and 2x. It's twice as big. But these aren't always going to be special. What if that was 29 degrees, or 38 degrees, or 72 degrees? Then you can't do it that way. You might have noticed something here. We could do this. We could shorten it. Instead of every time cross multiplying and then dividing, it'll work every time to just switch places. As long as you're going diagonal, x up to sine 30, sine 30 down on the bottom. Can't solve a proportion with the variable in the denominator. Let's try this one. Set it up. Of course, we're going to have to do two problems because we're looking for x and we're looking for y. Okay. Mark the 22 degrees. We're going to have to label everything, and the first thing I'm going to have you label is the hypotenuse. Find the 90-degree angles, shoot straight across the room or straight across the triangle. The hypotenuse is x. Where is this 4? All the way across from 22, which makes that the opposite side. Let's just stop there. Well, you could label this adjacent because it's the only one left, but let's work with the opposite side. We have to work with the opposite side because that's the one that has a number. So we have to work with O. If we're looking for x first, we're looking for the hypotenuse. We know the opposite side. We're looking for the hypotenuse. So we're going to use sine. So good to. Pretty much the same setup over here. I'm going to leave it where there's a lot of room because we have to find the other one. The sine of 22 degrees, don't forget your degree symbol, equals opposite over hypotenuse. I just showed you that shortcut. Let's use it. Cross multiply and divide, but cross multiplying and dividing is the same as switching places. Take 4 divided by the sine of 22 degrees. And I'll remind you, if you're using a graphing calculator, to make sure you're in the right mode. It has to be lit up as degrees, not radians. So that when you take 4 divided by the sine of 22 degrees, you're going to get 10.677. Let's go with 10.7. 10.7. So x equals, or is approximately, 10.7. Do a quick look. See if it makes sense. Could that be 10 if that's only 4? It could be. But now we have to find y. Same problem. This time we're using the adjacent side. We're looking for the adjacent side, but you still have to use the 4. That was given information and that's exact. We found our own hypotenuse and we had to cut it off and round it. So we're not using x. Always use the given information, which is opposite. We have the opposite side, we have the adjacent side. Well, if you look at how to spell SOHCAHTOA, we have opposite and adjacent, which means we're going to use tangent. Opposite over adjacent. So come back over here and do the math. What is the tangent of 22 degrees? When you know the opposite side is 4 and the adjacent side is y. Opposite over adjacent. Again, the y is in the denominator, so we're going to switch places and go with y equals 4 divided by the tangent of 22 degrees. Looks almost the same, but the fact that we're using the tangent ratio instead of the sine ratio is going to be different. So 4 divided by tangent 22 degrees equals 9.9. A little bit smaller than the hypotenuse. Y is approximately 9.9. It does have to be smaller than the hypotenuse. It doesn't have to be a lot smaller. If you wanted to check your answer, you could, Pythagorean theorem, but it's going to be off a little because of the decimals. All right, let's try another one. "25 degrees up in that corner. We're only looking for x this time, so that's nicer. It's a little shorter. Every time, the issue for most students is, how do I know which one to use? Should I use sine, cosine, or tangent? It all depends on the angle you're working with. As I said, go find your hypotenuse first and label it. Well, this time we know the answer to our hypotenuse. So we're going to use either sine or cosine because they have a hypotenuse. Then find what else you have. This is a 25-degree angle. This is adjacent or right next to the 25-degree angle. We need adjacent, we need hypotenuse. We do not need opposite, which means we're working with the cosine. Cosine of 25 degrees equals adjacent, x, over hypotenuse, 9. Ooh, a little bit different setup this time. Notice that the x is in the numerator. Before we had to cross multiply to get it up there and then divide. Well, this time we get to just cross multiply. Cross multiply. You put 9 up here in the front times the cosine of 25 degrees equals x. Multiply that 9, get it up there. And yes, go ahead and put it in the front. Multiply that out, 9 times the cosine of 25 degrees equals 8.2. We'll keep going to the tenths until they tell us different. So x is approximately 8.2. Probably could have put that down here. A little bit smaller than the hypotenuse again. How are we going to use this in real life? Because you want to find out how big this tree is. Solve for the tree's height. Anytime you get a real life problem like this, if it's a building, if it's a tree, if it's a telephone pole, we got to go with the fact that we think this tree grew straight up and down and made a right triangle for us. Because when it's not a right triangle, that's when we need pre-calc. We're not ready to do pre-calc yet. So it wants to know the height of this tree, so let's label that with our x. That's what we're looking for is x. We don't know if we're using sine, cosine, or tangent yet. Let's find what we need. Here's your 90-degree angle. Here's the hypotenuse. We definitely don't need the hypotenuse. So if you're spelling our acronym, SOHCAHTOA, we don't need the hypotenuse, we don't need the hypotenuse. We know we're going with tangent of 59 degrees. Which one is which? The x is all the way over there, which makes it the opposite side. Opposite over right next to the 59 or touching it is the adjacent side. X over 45. Here's another one that we set up to just cross multiply. We get 45 times the tangent of 59 degrees equals x. 45 times the tangent of 59. 74.9. Feet tall. Again, real life problem. Make sure that it's accurate or that it makes common sense. Yeah, we could have a 75-foot tall tree. It works. You might ask, sure, I can find the height of the tree, but how am I going to find this angle? There's such a thing as a clinometer, it's called. If we get a chance, we'll use those this spring and measure how tall some stuff is. All right. An escalator in LA rises 45 feet at a 35-degree angle. Find how far a person travels on the escalator. I have a great YouTube video. I'll save you. But if you YouTube broken elevator, it's kind of funny. Go back to it. An escalator in LA rises 45 feet. Rises 45 feet at a 35-degree angle. Here it comes. So the YouTube is escalator temporarily stairs. What happens if the escalator breaks? It actually makes me laugh pretty hard. So, Google it, YouTube it. How far a person travels on the escalator. Here's the escalator right here. How far are they traveling? That's our x. We want to know that distance. Where is x? It's across from the 90-degree angle. So that's the hypotenuse. Where is 45? It's all the way over here across from the 35-degree angle. So that's opposite. What uses opposite and hypotenuse? Sine. So the sine of 35 degrees equals x over 45. And remember, sine of 35 degrees is nothing more than a big old fancy ratio. So if we take this ratio and compare it to that ratio, we just start cross multiplying. How big is the opposite side compared to, whoa, were you yelling at the screen? How big is the opposite side compared to the hypotenuse? Again, change places, cross multiply and divide gets us to here. And we want to take 45 and divide it by the sine of 35 degrees, which is 78.5. Person travels 78.5 feet. That is a crazy long escalator. But it rises 45 feet. 45 feet, that's like 4-story escalator. We are in LA though, not in Madison, so could happen. Rising to the top of that tree. Great big mall you're probably in. All right, last two problems. We got to find the area of this triangle. Really? All in one day? Yep. Area of a triangle is half base times height. The base always has to be perpendicular to the height, so we're always going to be using the legs if it's a right triangle. We need the base and the height. We unfortunately do not need the hypotenuse. But we do need the hypotenuse to try to find the base and the height. This gets fancy. We do already have the hypotenuse. We know our 32 degrees is down in this corner, so we're looking for the opposite side and the adjacent side. We'll call the adjacent side base, B. We'll call the opposite side H for height. We need base and height. Let's find the base first, since that's what it says. 1/2 base times height. If we're looking for the base, we have adjacent over hypotenuse. I'm going to do that off to the side here. Adjacent over hypotenuse is cosine. The cosine of 32 degrees is B over 8. Cross multiply that, you find out that B equals 8 times the cosine of 32 degrees. And I believe we've had this talk before, maybe not. A lesson for you. You are not allowed to take 8 times the cosine of 32 on your calculator and use a base of 6.8. We know that this base is about 6.8, but it's not really. It's 6.7843847769. So when we type this in our formula, we're going to type in 1/2 times the base, which is 8 cosine 32, times the height. But we have to find the height. Because we're not going to round this answer, plug it in, round this answer, plug it in, and then plug it all in and round the answer again. We'll all get different answers. So now we have to find the height. Where is the height? It's opposite. Sine of 32 degrees equals height over 8. So what is the height? Cross multiply. The height is 8 times the sine of 32 degrees. Now you can type that in and make sure that we're about good. Sine of 32 degrees is 4.2. 4.2. That's the height of a triangle, about 4.2. But really we know it's 4.23935. So I'm going to put 8 sine of 32. You do not need to put these parentheses when you type it in. 1/2 times 8 cosine. Most calculators give you a parenthesis there, so you finish it, times 8 sine parentheses 32. Type it in like that. 1/2 or 0.5 times 8 times cosine 32. Close your parentheses. Times 8 sine 32. Close your parentheses. Hit equals 14.38, which is 14.4. Area of the triangle is approximately 14.4. Try it again. Slow it down if you have to. Okay, how big of a difference does it make if we did it the other way? And we said area equals 0.5 half times 6.8 times 4.2. If we rounded, typed it in and rounded again, 14.28. So if somebody does the work here and their answer is 14.3 instead of 14.4, I know that they did some extra rounding. And it'll be off by worse depending on what our decimals actually are. Last one, let's try this one. The height or the base times height of this triangle. I'm going to pause it and then show you how to do it. And you can try it on your own first because you have the base. All you need is the height. All right, pausing. You can come back to it after you've attempted. Okay, if you got 65.0 or as mine came out, 64.95, which rounds up to 65.0. Yes, you will put the 0.0 if it says round to the nearest tenth. If it says tenth, you got to show me tenths. Take a look at it and see if you got it. I know this was a long one. Thanks for hanging in there. Bye.